How can the current methods of producing nitrogen fertilizers be made more sustainable and less harmful to the environment? That's a question that has been on the minds of scientists and environmentalists alike. The issue at hand is that the widely used Haber-Bosch process for creating nitrogen fertilizers relies heavily on natural gas, contributing to a substantial carbon footprint. Fortunately, an alternative appears to be on the horizon. Imagine the power of the wind and the sun being harnessed to create low-carbon footprint nitrogen fertilizer. Instead of relying on fossil fuels, researchers are now exploring the potential of renewable energy sources, such as wind and solar power, to generate this essential agricultural component. The process that makes this possible is electrolysis. By using water and electricity, hydrogen can be generated without any carbon emissions. Small-scale experiments using wind or solar-generated electricity have shown promise in producing what is known as renewable ammonia. Although this technology is still in the stages of optimization and faces challenges in competing with established industrial-scale processes, it is inching closer to commercial feasibility. Think about medium-scale plants located in agricultural regions with ample wind and solar electricity generation potential. These could drastically minimize transportation footprints and buffer the market from global price fluctuations. Consider the potential to further decarbonize fertilizer production by linking it with bioethanol plants. By capturing CO2 emissions from fermentation and using it to produce urea, a more easily stored and applied form of nitrogen fertilizer, we could reduce carbon footprints even more. This would not only be beneficial for the environment, but also for the business and logistical aspects of the industry. So, what have we learned today? We've discovered that the current methods of producing nitrogen fertilizers, namely the Haber-Bosch process, have a significant environmental impact due to their reliance on natural gas. However, researchers are exploring the use of renewable energy sources like wind and solar power to produce low-carbon footprint nitrogen fertilizer. This process, known as electrolysis, is showing promise in producing renewable ammonia. The shift towards renewable ammonia production could also boost the solar and wind energy sectors by providing utility during peak production periods. The potential to further decarbonize fertilizer production by linking it with bioethanol plants adds another layer of environmental and economic benefits. It's an exciting time as we witness the merging of agriculture and renewable energy. We are on the brink of a revolution, one that could significantly reduce the carbon footprint of nitrogen fertilizer production, making our world a cleaner, greener place.